Here's the bell work. Let's go ahead and go through this one. So we'll give the answer in lowest terms if it's needed, right there. But like I said before, I like to work with just the numerator first. You can start with the denominator if you like, but it also means for me, I pretty much just ignore the denominator for now, okay? So using the order of operations, I see there are parentheses, but there's nothing to do inside the parentheses, so I have to go straight to exponents. And there is an exponent, 6 to the power of 2. You can type that into the calculator if you need. 6 times 6 is 36, right? So everything else remains. I still got negative 8, that's a positive 36, and then minus negative 5 here, all right? So that is exponents. Is there any multiplication or division? You could say yes, but really there is not at this point. So we're going to move from left to right using addition or subtraction, and the addition comes first. So that's a negative 8 plus 36 right there, which would give us 28. So then I now have negative 28 minus negative 5. And I don't usually subtract with negatives for me, so I'm just going to use keep, change. And again, most of you have been showing it like this, which is okay. That's great. In fact, I like it, so I'm going to steal it. So that becomes 28 plus 5, which is 33. Okay, and that completes the numerator right there. Then we'll go to the denominator. So let's see what it looks like. It's negative 9 plus 3 minus 1. No parentheses, no exponents, no multiplication or division. So we'll move from left to right doing addition or subtraction. And yeah, we'll start with this addition right here. That's negative 9 plus 3, which is negative 6. And then I will still subtract the 1. And yeah, that's the final operation there. So negative 6 minus 1, that should give us negative 7. Okay, so we end up with negative 7 as our denominator in the end. And it said leave this in lowest terms, so that's what I'm going to do right here. I'll call that lowest terms. There we go. Some of you may say, well, we can change that into a mixed number. Yeah, but that doesn't really change it in for lowest terms. It just changes its notation right there. But here's our objective. I can substitute numbers for letters and evaluate those expressions, which is what we call evaluating expressions. So take a minute, copy that down on the classwork, and then we'll get started on the lesson. The stuff that we're going to be doing in 8th grade, this is a very important skill to have in mathematics. So you've seen it before when you check your work. For example, in the past, it's a 3x equals, 15. And then you'd say, well, divide both sides by 3. Remember that stuff? We're not doing that today, but then you found in the end that x was 5, right? But then you'd go back to the original equation, 3x equals 15, and you'd replace the x with 5 like you found, and just check for truthfulness. We put a question mark over the equal sign. Well, then you'd see 15 equals 15, and that's true. Then you would know that x equals 5 is the solution. Now, that's one of the applications you've seen already, but there's other applications which are going to be equation-like, okay? But in the future, they're going to have 2 variables, not just one. So we're going to have an x here and perhaps a y over here or over here somewhere, all right? And we won't be solving for these. We're just going to be able to plug them in ourselves. But if we can't do this, then none of that will be applicable because we'll be too confused on what the crap we're doing, all right? So we have to be able to look at formulas and replace letters with the numbers either that are given, but in the future, like I said, you'll be having to choose the numbers yourself, okay? So variables. Usually we just use x, like it says here. When you're writing your own equations, it's possible you may use other letters, and we'll see some other letters today. The most common ones are x, y, and z, and then also a, b, and c, but anything beyond those is kind of a crapshoot, but we try to avoid o and l, lowercase l's, because they look like zeros and ones, and then I and e mean usually something very different in mathematics. We try to avoid those, okay? But yeah, when we start seeing equations with 2 variables, you may see the letters represent many different values, and we'll make tables usually to figure out their correspondence there. Yeah, and then also when you see word problems, it's always nice to actually define the variables. Like, yeah, so yeah, you could say x equals hours walked or x equals tickets sold or something like that. But again, maybe we'll deal with two variables. X could be number of children that entered the amusement park, and y is the number of adults that entered the amusement park, something like that. So algebraic expressions, they're going to start again with letters, and let's see. I guess a common one would be what is it? 9/5. No, I have that backwards. 5/9 f minus 32, something like this. Seems like it should be in parentheses. So this is a Fahrenheit to Celsius conversion. It's an equation, but again, if you found some kind of Fahrenheit degrees, you'd plug it in there, and then you could find the corresponding Celsius degrees. Okay. Now we're only going to be dealing with expressions, and expressions do not have equal signs. So you may see something like this. Okay. But then, even if you were to solve this, it does equal some kind of Celsius degrees, but it's some kind of formula, okay? So they have some letter, and for today, like I said, they're going to tell us what, in this case, the Fahrenheit degrees would be. So let's see what 100 degrees Fahrenheit is. Then you replace the 100 in for the F. You wouldn't show the F anymore, but that's what makes it algebraic, is that it has a letter in the expression now, okay? And then you just evaluate. Once you get that number replaced in for the letter, boom, you just pretty much throw that in the calculator and be done with it. So here's our first example. Very basic expression, x minus y, but then they've given us x and y values down here. So let's show the equation, x minus y. Right here they said x is negative 12, so I go in and I replace x with negative 12. Now when you put these in, you should use parentheses. I would recommend using parentheses all the time, but we definitely need them for negatives, okay? So whenever you see a negative value, make sure you put parentheses around it, because otherwise when you put it into the calculator, it may think you mean something else. Okay, and that goes back into some computer programming or coding or whatever you want to call it. And then it says the y is negative 8, so let's replace the y with negative 8. Then we're just going to solve this. Okay, so I put that negative 8 in parentheses. Now, you could just put this directly into the calculator. You would be fine, and that would be good. Some of you would use keep, change, change. It's up to you. So for me, I'm going to put that minus negative 8 in there, but you'll need to remember when you put this into the calculator that the minus and the negative buttons are different buttons. Okay, and so that would give us, when you combine these in the calculator, or otherwise even, negative 4. So once again, I just can't stress this enough. They'll give us these numbers. In the future, you'll have to figure them out yourself and then find other corresponding values that go with each other. But that will be when we see equations. Here's two more, but they're going to give us one value for both of these. So we just need to work on these one at a time. So down here at the bottom, I'll start with the first expression, 3x to the power of 2 minus 41. And right here it says x is 6. So I will replace the x with 6. Now this becomes order of operations stuff. And, well, let's use some order of operations. Let's see the exponent. There's no parentheses to work with, so just start with this exponent. That's 6 to the power of 2. 6 times 6 is 36. Then I get 3 times 36 minus 41. Now we have multiplication or division from left to right. And I see the multiplication there. 3 times 36 should be 108. Now minus 41. And while I probably should be able to do that in my head, 108 minus 41 on the calculator is just as good. And when I do this subtraction, it gives me 67. Now I did that operation by operation, but we can put this in the calculator. 3 times, I'll put parentheses 6, close parentheses, to the power of 2. Minus 41, enter, boom, 67. So we did do that correct. And yeah, you could have just typed that into the calculator from the beginning. But there's that second expression, so let's go and do that one. X minus 4, but this one's to the power of 3. So we need to learn how to do powers of 3 now, because in the calculator, it doesn't have a power of 3 button, but there, we can force it to, all right? And then we still know that the x is 6, so I'm going to replace that with 6. You can put parentheses around it if you like, but this one's positive, so you wouldn't necessarily need to. So, order of operations, I would start with this set of parentheses. 6 minus 4 is 2, so then it's 2 to the power of 3. Now, some of you would probably just do this in your head, 2 times 2 times 2, and you would know what that is pretty quick. But I'm going to put this into the calculator with the exponents so that we can get our first experience with, well, exponents. So I'm going to open a set of parentheses with it's the button right above 8, and then I'm going to push 2, and I will close that set of parentheses. That's the button right above 9. But now I've got to get that exponent of 3. So I'm going to push this button. That's one button to the left of 7 and one button up. Looks like a little arrow. And you'll see on the calculator, it looks like this now. So you got the 2 in parentheses, but then your cursor is right here, right? So that's your cursor. That means it's in exponent mode. So I just got to tell it the exponent that I need, which in this case is 3. So I will push 3. So that's the full expression, and now, of course, you can see a 3 right there. But I'll just push enter, and it will give me 8. Boom. Okay? And yes, you could have just put this in from the beginning. Parentheses, 6 minus 4, close parentheses, and then power of 3, enter, boom, still 8. All right, here's one, x to the power of 2 plus 6x plus 8, all over x minus 2. But this one, it says here x equals negative 2. That's okay. So let's go and write this out then. So there's the expression that it gave us. We know x is negative 2. And since x is negative, you definitely need to use parentheses around this one. If you don't, you're going to get the wrong answer. If you put it in the calculator anyways, okay? Because the calculator will think that you mean something different. And I guess I'll explain. Let's replace all their x's with negative 2, right? So there's 1. There's a negative 2. Here's another x. Let's replace that with negative 2. And yes, I am using parentheses on purpose. And then this x here in the denominator, still negative 2, okay? Now, what if you don't use parentheses? Well, I don't know what it would do with the 6, negative 2. You'd have to put multiplication between there. Down here, you wouldn't find any problems. It's this one, okay? Because this, if you don't put the parentheses there, right, let me show that. So if you don't put parentheses there, it's going to think that you want 2 to the power of 2 and then just make it negative, which would give you negative 4. But with the parentheses, that's negative 2 times negative 2, which is positive 4, all right? So you'll need to remember that, because otherwise, if you don't use parentheses with negatives, you will get the incorrect answers, and well, we don't want you to blame the calculator because it just did what you told it to do, okay? So once again, I'm going to start with the numerator. So goodbye, denominator. We'll come back though. And in the numerator, I have that exponent of 2. There's no parentheses there, right? So that's negative 2 to the power of 2. That's negative 2 times negative 2, which is positive 4, right? Nothing else changed there in the numerator. So there it is. Oh, against the plus sign. So there's exponents. Well, then there's multiplication between the 6 and the negative 2. So let's go and do that one. 6 times negative 2 would be negative 12. So now I got 4 plus negative 12 plus 8. And again, you don't really need to use keep, change since we're using the calculator here, but 4 plus negative 12, of course there's more negatives than positives, so we know the answer is negative. 12 minus 4 is 8. That's negative 8. Negative 8 now plus 8. That's not bad. They're opposites and they're being added together, so that would just give us 0 here right at the end. So that's our numerator of 0. Now some of you guys know some rules about 0, but we still need to consider what the denominator is. So let's see what that is. And that's just, well, oh, that's negative 2 minus 2. Once again, if you're going to do that by hand, some of you may have used keep, change. Negative 2 plus negative 2. You could have put that into the calculator. You would have gotten negative 4 there, okay? So we end up with negative 4s throughout all the denominators, like this, and this, and this. Okay? So that becomes 0 divided by negative 4. Just a little bit more space. And 0 divided by anything, I guess, but 0 is 0. That's our final answer here. After that division, that's done. This is the kind of problem that most students struggle with. I mean, not because they can't put it in the calculator, but because it's just big. And when students see it, they tend to, not most, but some tend to just give up. And again, that's the x to the power of 2 thing, which could throw you off. You need to put negatives in parentheses, especially with exponents. All right, here's another one. 4b minus, see, we got two letters on this one, a's and b's. So let's go and write this out for us. 4b. All right, and they gave us both values. I'm going to start with a. I just always try to start with the first one they give us. And there's only one a in this expression, so I'm going to replace it with 2. Now, it's positive. You can still put it in parentheses if you like, but it wouldn't be necessary. And then b here is 3, so I'm going to replace the b with 3. Both b's, actually. Now, I will put it in parentheses next to the 4 because that's multiplication. But again, in parentheses, we wouldn't necessarily need another set of parentheses, okay? Now, the order of operations isn't too bad on this one, so that's what I'm going to do. Start with the parentheses, 3 minus 2. See that? That's what I mean. It's just 1. Then you got 4 times 3 minus 1. So that's the parentheses. There's no exponents. Let's go to multiplication or division, which is 4 times 3. That would be 12. Now I have 12 minus 1. See what I mean? That's and some students may put that in the calculator. And if you did, that's fine. You should get the same answer. But some of you would be like, hey, I can pretty much do that in my head, and that'd be fine if you did. But showing the work here isn't that bad. Here's another one with 2 values, x's and y's. So let's go ahead and get to it. Let's go and just rewrite this, though. And in this expression, it says x is negative 1. And since it's negative, I see right here is just an x. So I don't really need another set of parentheses right there. That'd be redundant there, okay? But in this one, I will use parentheses because there's more operations to perform. So there's an x, which is negative 1, and here's another x, which is negative 1. But then it says y equals 3, so let's go and replace that y with 3. That's positive 3. Again, you can still put that in parentheses if you'd like. It's not going to be a problem whether you put it in the calculator or otherwise, okay? So, order of operations. Yeah, I'm going to start with this set of parentheses here. That'd be negative 1 plus negative 1, which is negative 2. So now I got negative 2 minus, well, we'll just put 3 there. Negative 2 minus 3, you could use keep, change there to make that plus negative 3. So when you combine these, you should get negative 5. Okay? Now out in front, we still have this multiplied by negative 1 there. So now I get negative 1 times negative 5. And again, if you need a calculator for that, that's fine. That shouldn't be something you feel ashamed about because that's what calculators are for. But I end up with a positive 5 on this one. So let's go ahead and evaluate this one. It gives us two letters, A and C on this. No problem. We can do that. Let's go ahead and just rewrite the expression though. A plus 3 minus C over 6. All right. So it says here that A is negative 5, so let's replace the A with negative 5. And there's only one A. It is negative 5, so I'm going to put this in parentheses on purpose. And then it says here that C is 12, so let's replace that C with 12. Now you may look at this one and be like, well, there's no parentheses, but remember, when you see fraction lines like this, we do treat this as parentheses. So I'm going to do this division first. That's 12 divided by 6, which comes out to 2. Okay, so now I have negative 5 plus 3 minus 2. There are no exponents. There's no multiplication or division from left to right. So now we're on additional or subtraction from left to right. And there is some addition between the negative 5 and 3. So let's combine those. There's more negatives than positive. 5 minus 3 is 2. Negative 2. So now I have negative 2 minus 2. And whether you use keep, change, -2 plus -2, or just put it in the calculator. You'll get the same answer here, -4. Well, here's another one. And yeah, let's go ahead and rewrite this expression. You'll notice when I rewrite this, I kind of gave myself a little bit more space between A and B. That's why I don't have them so close together. I can't write them. All right, so we'll start with the A over here. And it says that the A value, and there's only one A in this, but it is 3. So I go in and I replace this A with 3. I'll put this one in parentheses because it is multiplied by the B value. And then it says that B equals 12. So there's 2 B values, and we need to replace both of them with 12. So there's one B, replace it with 12. This one's positive, so I don't really need parentheses. You're welcome to use them if you'd like. I'm going to go and put them in. Let's replace the other B also with 12. So, order of operations. Parentheses. Now, there are parentheses, but there's nothing to do in the parentheses. So, exponents. Nope, none of those. Multiplication or division. Now, in what I've seen here from looking at the quizzes, some of you are still doing things out of order. You'd say, I have to do this multiplication first. No, you should do this division first because it's the first operation we see to the left between multiplication or division. So we got to do that division first. 12 divided by 3 is 4. Okay, so then we look at the rest of this expression. And now, scanning to the left, now we can see this multiplication, and we'll go ahead and do that. So 3 times 12 is 36. Now we got 4 plus 36 divided by 3. And now we would look at that division there. Okay? So 36 divided by 3 is 12. So we end up with 4 plus 12. And there's only one operation left. So we'll just do that. 4 plus 12 is 16. All right, here's this one. And now we have 3 letters to replace still. Hopefully that's not a problem. Let's go and rewrite this. All right, there's our full expression. And again, I've given myself a little space between the X and Y so that I can actually write the values in. And again, I just kind of start with the first value, pretty much in alphabetical order. X is 2 on this one, so I replace my X values with 2. So there's 1. X, I'll replace it with 2. And again, it's positive, so I don't really need parentheses. This other X here, this one's being multiplied, so I will put this one in parentheses though. And that's all the X's. Next up, Y's. Y is 1, and here's a Y. It's being multiplied by the X, so I will put that in parentheses as well. Multiplying by 1 is great. And then we also have these other 2 Y's here in this other set of parentheses. But Y is 1, so that's 1, and I'll put that in parentheses with the exponent. So, we now have the Z also, so let's go and replace the Z with 3. There it is, only one Z. And it is 3. Well, that sets up our expression, and all we got to do is use the order of operations. I'm going to start with this set of parentheses. Okay, so first set of parentheses, you could have started with the one on the right, it wouldn't matter. But I'm going to start with this one. So in that set of parentheses, in the numerator, I have 2 times 1, which is 2. Then I'll have to divide it by 5. Notice I'm not worried about that exponent right now because I'm just working on the inside of the parentheses. And in fact, that's as far as I go on that set of parentheses. Let's do the other one. So the first thing I notice here is on the inside we got the exponent. That'd be 1 times 1, which is, well, 1. So that becomes 1 minus 1, which is 0. Okay, so let's see what this expression looks like now. First, we still got this 2/5 in parentheses there. And we got still this 2 minus 3 plus that 2/5. And that's just minus 0. Some of you would probably get rid of that at that point. That's what we got as of right now. All right, so that's parentheses. Oh, I almost forgot that other exponent, didn't I? Remember, that's to the power of 2. 2/5 to the power of 2. Just put that in the calculator, and you will get 4/25 after raising that to the power of 2. So this is now what we have. 2 minus 3 plus 4/25. And again, I'm going to keep that minus 0, even though it's not going to change anything in the end. So now, that's exponents, any multiplication or division. Well, you could say the fraction line, but that's a simplified fraction line. We're just going to work with a fraction and let the calculator do the work from there. So I'm going to start with this subtraction. 2 minus 3 is negative 1. Of course, nothing else changed there. And we got the plus sign. Negative 1 plus 4/25. And when you combine these two, you get negative 21/25. And then minus 0, that's not going to change anything, so this ends up being our final answer right here. Now, we could have gotten this in the original expression if we just plugged it all into the calculator, right? So 2 minus 3 plus parentheses, fraction button, 2 times 1 all over 5, close parentheses to the power of 2, minus parentheses 1 minus 1 squared, close parentheses, enter, and I get negative 21/25. So that checks off. It just made sure that we did the order of operations correctly right there. We're just making up our own. So this is a nice expression. We haven't seen one like this, but hope you guys know how to do this. Right here, it says x is negative 2. So I go in and I replace x with, well, negative 2. Don't forget to put parentheses around it because it is a negative. And then y is 5. Now, you don't usually need to use parentheses around it, but I am going to because it has an exponent. Okay? So, let's go and do this one. Starting with the inside of the parentheses, I got negative 2 to the power of 2, which would be negative 2 times 2, negative 2, which is positive 4. Then I also have 5 to the power of 2. 5 times 5 is 25. Okay? So parentheses, this would be 4 minus 25, which we can do. So then we got 4 minus 25, which is a negative 21. Now we're not forgetting about that exponent of 2 on the outside of the parentheses. But I'm going to type this into my calculator because I can't do negative 21 to the power of 2 in my head. So parentheses, negative 21, close parentheses, exponent of 2. I get positive 441. And that should do it. So there's our objective. I can substitute numbers for letters and evaluate those expressions.